Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? You don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. Saturn isn't the only planet that has rings. Gas giants Uranus, Neptune, and Jupiter have rings of their own, but they're thin and almost impossible to see. NASA can convert plasma waves, radio waves, and magnetic fields into audio tracks and listen to what's happening in space. They record all kinds of intriguing sounds, from beeps to ambulance-like howls. At the same time, space itself is an eerily silent place. There are some sound waves and vibrations, but people can't perceive them. Oceans cover 70% of the Earth. On average, the ocean is 8 Empire State Buildings deep, and less than 5% of its mysterious depths have been explored. It's even possible to find lakes and rivers beneath the ocean. They are denser than the rest of the water surrounding them, so you can clearly see the difference. When sharks need their morning joe, they go to a cafe too. Back in 2002, researchers found an area in the Pacific Ocean called the White Shark Cafe, where great white sharks come during the winter. They simply hang out, tell jokes, and laugh at stories of how many humans they've scared, and then go back to the coast to scare us a little bit more when the weather gets warmer. Have you had a great white latte? Try one. You can taste garlic with your feet. Rub a clove right in your feet. Of course, take the socks off beforehand and wait for it. The chemical responsible for its unique smell can be absorbed through the skin, even though the clove never was in your mouth. By the way, lobsters can try out the same experiment. Well, they actually taste food with their feet. In Tibet, there are black diamond apples that aren't green or red, but dark purple. The place where they grow has plenty of ultraviolet light over the day, while temperatures drastically go down during the night, which makes the apple skin get a darker color. Australia has a lake of a naturally bubblegum pink color. The unusual color is there because of the pigment from a certain type of algae living there. There is a specific type of jellyfish that's actually immortal. Hey, I could see that as a logo for a life insurance company. The Earth is orbiting the Sun, but not at a fixed speed. We don't sense it, but it's slowing as time goes by, so our day will become 25 hours long, in around 175 million years. So don't plan that extra hour in your schedule just yet. Space is huge, duh, but there's obviously lots of empty spots, since there are more trees, 3 trillion, on our planet than stars in the Milky Way, only about 300 to 400 billion stars. Ostriches don't actually hide their heads in the sand. When they sense danger, they lower down their head, neck, and body to the ground, which makes them a little bit less visible to predators. Their light-colored necks blend in with the sand, so it only looks like their head is hidden down there. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish-red sky turns blue as the sun goes down under the horizon. It's because Mars is much further away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres, and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique system of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. This one is the oldest, largest, and at more than 12 billion light-years away, it's the farthest known to humankind.
Aristotle once said that gold was water solidified in the ground and mixed with the sun's rays. Others were sure that gold was made with the help of the philosopher's stone. When the ancient Incas first saw gold, they decided that this metal, falling from the sky, was the tears of a mythical creature. But its real origin seems much more epic. Let's go to a very distant past, to the time when there were no people or animals, to the time when dinosaurs didn't exist yet, to the era when the simplest forms of life were just being formed. Our planet resembled a huge cauldron of chemical elements. There were erupting volcanoes, earthquakes, and lightning flashes all the time. It was about 3.9 billion years ago. During this period, huge asteroids flew through our solar system. They fell on Mercury, Venus, Earth, and Mars. It's possible that asteroids also fell on the moon and left large craters on it. There was a real apocalypse on our planet. But fortunately, no one felt it because there was no life yet. Along with the destruction, the asteroids brought metals. But were there metals on Earth before that? Of course. The core of our planet is mainly made up of metals such as iron. From there, it spreads to Earth's crust, mixes with magma, comes into contact with oxygen, and combines with other elements. But how did they get into the core? Simple hydrogen and helium atoms merged and formed heavier elements inside giant stars. Then, supernovae exploded and formed big clouds of dust and gas. These clouds reached our galaxy and began to revolve around the sun. Over time, this dust and the remnants of stars formed planets. One of them was our Earth. Metals lying in the bowels of our planet are difficult to get, and we wouldn't have the technology we have now if it wasn't for that meteor shower that left metals on Earth's surface. There are two theories. The first suggests that powerful supernova explosions far from our universe formed a lot of metals from the periodic table. During the explosion, nuclear fusion started, and it created atoms of gold. Then, the blast wave threw those hot pieces in different directions. They flew for a long time, cooled down in cold space, and reached our solar system. Another theory says that gold and other metals appeared because of the merger of two neutron stars. These are powerful giant stars that are many times smaller in size than the Sun, but several times heavier than it. These are objects with tremendous gravitational force and density. Their collision formed an intense gamma-ray burst of radiation that could synthesize gold. In 2017, astrophysicists observed the collision of two neutron stars for the first time. They found traces of heavy metals, including gold, using gravitational wave detectors. So this theory seems more likely. And what if we go even further? Where did stars come from? Clouds of dust and gas are scattered throughout the universe. They mix, combine into one mass, and grow like a snowball. They squeeze each other and form a gravitational force. When all the material collapses, it starts to heat up, and then this surge of energy creates a star. Some physicists assume that stars, during their lifetime, can produce most of the elements of the periodic table. If this theory is true, then our body also consists of stars. We may be part of some gigantic supernova that exploded billions of years ago at the other end of the universe. More than 50 years have passed since the appearance of this theory, but no one has proved or disproved it. Okay, let's get back to gold. One of the largest gold deposits in the world is in southern Africa. Scientists believe that the precious metal appeared there more than 2 billion years ago after the fall of a giant meteorite. People are sure that gold is hidden in the world's oceans. Anywhere from 10 to 20 million tons of this precious metal can be underwater. But those are not large stones, but tiny particles dissolved in liquid. The extraction of such gold is too expensive. Now, let's find out how people mine gold and turn it into jewelry. At first, people find gold deposits, large plots of land or rock inside which gold is hidden. Workers begin to use picks, shovels, and machines to extract shiny pieces from the rock. Then these pieces are dissolved in a special acid that separates the gold from the solids. After that, other substances get removed from the precious metal by melting or using gaseous flora. When the gold is purified, it's checked for purity. 99.9% is the benchmark. Done! Your gold is ready to use. You can turn it into jewelry or part of an electronic device. The rarest metals on Earth also got here from stars. I'm talking about rhodium and iridium. They are several times more expensive than gold, not because of their beauty, but because of their practical value. For example, rhodium and iridium can turn harmful gases into harmless ones, and 90% of the demand for this metal falls on the automakers market. People use these metals in the manufacturing of auto catalysts. They are needed to clean harmful exhaust. When toxic substances produced during fuel combustion come into contact with these precious metals, they become their safer forms. A micro-layer of rhodium and iridium is applied to the walls of the catalyst cylinder. Gold, platinum, rhodium, and iridium are the most expensive metals. But what about the most durable ones? It's a little complicated to determine one winner because the strength of a metal depends on 4 criteria. First, there's tensile strength. This is the ability of a metal to resist tearing. For example, modeling clay has a low tensile strength because you can easily stretch it in different directions. Among metals, tungsten is perhaps the most difficult to stretch. Another criterion is compressive strength. This is the ability of a metal to resist compression. And here, chrome is one of the strongest. The third criterion for the strength of metals is yield strength. To test this, you need to make a rod or beam from any metal and then try to bend it and break it. The metal that shows the greatest resistance has a high yield strength level, and titanium is pretty good for that. And the fourth criterion is impact strength. This shows how strong the metal is when it gets dropped or hit. In this regard, iron shows a good result. Each metal has its own strong and weak sides. Chrome, for example, has a high resistance to compression, but it's weak if you try to stretch it. Therefore, people make metal alloys to combine their strengths. Okay, we've learned about the rarest and most expensive metals. And what about other elements? What's the rarest substance in the world? Meet astatine, the rarest element on the planet. There are about 0.8 ounces of this substance found in the whole world. The rate of its decay is equal to the speed of its formation. Therefore, the amount of the substance in nature doesn't change. People discussed it in the 1800s and discovered it at the end of the 19th century. But even now, after so many years, we know little about this element. In 1869, the creator of the periodic table, Dmitri Mendeleev, learned that there was a certain substance numbered 85 in the group of halogen elements. This group of nonmetals includes such substances as fluorine, chlorine, bromine, and iodine. So astatine is considered the heaviest of all known halogens and most similar to metals. It has a low melting point and conducts heat and electricity poorly. It's brittle in solid form and has a dark color. Even today, scientists don't know all its properties. It's almost impossible to find it in nature, but chemists have learned to synthesize it artificially. People don't know how to use this element because it's too radioactive. But in some laboratories, scientists conduct experiments using astatine to treat thyroid diseases.
Here's something cool that scientists have discovered recently: Schrodinger's black holes. Yep, the scariest objects in our universe turned out to be even more terrifying. Now, we know that they can also exist in many states at once. But what does it mean? Let's find out. Black holes are mysterious titans of our universe. Sometimes it feels like the more we learn about them, the less we know. We discovered them quite recently, in the 20th century. And since then, we've been finding various black holes all over the universe. Their sizes range from the size of a small town to horrifyingly unimaginable. But their most important feature is probably their huge mass. And that's where a recent study comes to play. Scientists have discovered that black holes have very unusual quantum properties. They found out that each black hole can be both large and small, light and heavy, no longer living and alive. Well, maybe except for the last part. Let's hope that there aren't actually any living black holes. That would be great. But the main point of the discovery is that each black hole can be in all possible states at the same time. It sounds weird, doesn't it? What is it actually supposed to mean? Well, the ability to be everything at the same time isn't a new concept in science. This is what physicists call a superposition, or, to put it simply, a state of uncertainty. Quantum physicists discovered this first in tiny quantum particles. They noticed a very strange thing. As long as we don't observe a particle, it literally exists in all states at the same time. And only when we start interacting with it, for example, looking at it, measuring it, or just doing something, only then does the particle decide what state it should be in. Here's an example of this. Imagine that you have a ball in a box. You don't know what it looks like, and the thing is, as long as it stays in the box, the ball is all colors at the same time. Only when you take it out of the box does it finally choose one color. All this happens instantly, so you don't notice it. For you, the ball has always been blue. Sounds pretty scary, right?
What?
And it raises a lot of questions. For example, how do these particles understand that we're observing them? How do they decide which state to be in? And what does our world really look like if we only see what is shown to us? Of course, this discovery caused a huge stir in the scientific community. No wonder, it does sound a bit unusual. That's what physicist Erwin Schrödinger also thought at the beginning of the 20th century. The ideas of quantum theories seemed delusional to him. That's why he decided to challenge them. He conducted a famous experiment. You've probably heard about it, even if you don't know anything about science at all. Yep, the infamous experiment with Schrödinger's cat. So, what was the point of the experiment? First of all, we have a box and a cat. In the box, there's a container with toxic gas and a special mechanism. Every hour, there's a 50% chance that this mechanism will either open the gas container or not. If it happens, the poisonous gas will be released and the poor cat won't make it. If this doesn't happen, the cat will remain alive and well. Don't worry, this was a purely hypothetical experiment. No cats were harmed in the process. But let's imagine that we did lock a cat in a box and waited for an hour. It's time to check the result. And here's where we get close to the most interesting part. How do you think this situation would end in our regular world? Well, probably within an hour, the container would either open or not, and that would be the moment sealing the cat's fate. After that, we just need to open the lid to find out the answer. But in quantum physics, everything is much stranger. According to it, until we open the box, the cat inside would be both alive and not alive at the same time. In other words, the universe itself doesn't know what to do with this cat. As if the poor animal is on the verge of two worlds inside the box. And when you open the lid, the universe will select a random result of the experiment. So why do we do all this to a poor kitty? Well, initially, Erwin Schrödinger wanted to show how stupid it all sounded. But then, he accidentally proved that quantum physicists were right. The situation turned out to be pretty funny. It went like this. Ha ha ha, these quantum physicists have no idea what they're talking about. According to their logic, the cat in my box should be both alive and not alive at the same time. Wait, hold on. Uh-oh. They're right. Schrödinger received the Nobel Prize in 1933, even though it wasn't for this discovery. And in 2022, 3 more scientists received the Nobel Prize for another discovery in this field.
Thank you.
These scientists were Alan Aspect, John F. Clauser, and Anton Zeilinger. They got it for their experiments that involved entangled quantum states. What does all this tell us? Guess now we'll have to look for explanations in some kind of quantum mechanical magic. Unfortunately, humanity isn't developed well enough to test any of these theories, yet. But we have many cool assumptions. For example, the theory of parallel universes is one of the attempts to explain this phenomenon. Remember that ball in the box? Basically, according to the theory of the multiverse, there's an infinite number of different realities. So, if you don't know what the ball looks like, it kind of exists in this interdimensional, uncertain state. But when you open the box and look at the ball, you get transported to a random reality. For example, to the one where it's blue. It sounds pretty incredible, but still exciting. Alright, but why do we need all this info now? Why is it connected to the recent discovery? You see, scientists thought, if teeny tiny particles in our universe behave like this, then what about some giant space objects? And so, they decided to direct their devices not into the microcosm, but into distant space. American and Israeli theoretical physicist Jacob Bekenstein was the first to suggest that black holes may have the same weird properties, but this theory had to be tested. The research itself was aimed at finding a connection between quantum particles and black holes. The researchers created a computer structure in which they placed a simulated quantum particle directly outside a giant simulated black hole. And in the end, this analysis showed that, yep, black holes could also exist in several states at once. For example, they can be incredibly massive and at the same time have no mass at all. And each of these mysterious space gates can have several masses at the same time. The modeling showed that these superimposed masses were, in fact, in certain determined bands or ratios, as predicted by Bekenstein, said the physicist Magdalena Zeik, referring to the study. It's not really clear yet what it all means, and this discovery alone hasn't brought us much closer to understanding how our universe works, or what happens inside black holes. We have realized only one thing. Everything around us is much more complicated and more fantastic than we think. Who knows? Maybe black holes are portals between these parallel universes. At this stage, it's impossible to disprove this. In other words, the universe has once again shown us that it is stranger and more mysterious and fascinating than we could imagine. Let's hope that in the future, we'll be able to understand at least a bit of what's going on in it.